this morning. It was like people throwing buckets of seawater on us. But we're all nice and warm and happy to be on board with you. So we've been doing talks with Holland America for a little over 10 years. I think it's almost 12 years now. And it's really a great opportunity for us to share a little bit about the United States Antarctic program with you. And it's a surreal experience for us. To try to put things in perspective, at Palmer Station right now, we have 39 people, I think. 39 people at the station. I think you have 1,300 people on this ship. So it's a little overwhelming. So, all right, so my name is Bob Farrell. I'm the station manager at Palmer Station. I've had the privilege of serving as a station manager for 14 years now, 14 or 15 years. Yeah, it's a great experience. It's a great job. I get to work with wonderful people, really dedicated individuals. And we are supporting science. So I'll start off with giving a quick overview of the United States Antarctic program. And then we're going to have Mark come up and he'll share with you a little bit about the science that we're doing at Palmer Station. So the United States Antarctic program is administered by the National Science Foundation in the U.S. And so the National Science Foundation, even though it's called Foundation, it's actually a government agency. They fund researchers in all different disciplines to come to the Antarctic to do their investigations. And they range all from Mcmurdo Station, that's where a lot of the science and field camps around McMurdo, to the South Pole, to here at Palmer Station, as well as a couple of research vessels, which I'll show you in a minute. When you look at the research that's funded in the Antarctic, you can generally group it into three areas. And the first group of researchers are folks coming down to understand Antarctica. So just like they would go anywhere else in the world, they're coming down here to understand why things are the way they are. So why are these animals here? And how did these landforms come about? Sort of the interactions of the ecosystem. Then there's another group that come down to try to understand how Antarctica, what role Antarctica plays in some of these global systems. So we have sensors around the continent, and we do measurements that contribute to some of these global models that are used to try to get an idea of how changes now may affect us in the future. So we feed into these global data networks as well. And then the third group of researchers are down. It's kind of interesting because they travel all the way here to the Antarctic, but they're not actually studying Antarctica itself. They're down here because of the circumstances here are particularly conducive to the type of work that they're doing. So as far as understanding Antarctica, technology has allowed us to explore even more than we did in the early days. So science has been going on here for decades now, and recently through, this is a great example of better understanding the continent. This is the AGAT project, which was a international collaboration. And what they did is they chose an area that they knew there was a mountain range under the ice. And they wanted to see how detailed they could get a map of it. And they flew these small aircraft with sensors under the wings, and they flew a grid pattern over and over, and they developed this three-dimensional map, very detailed map, high-resolution map, of what's going on beneath the surface. So if you flew over this area, you just see flat white. But underneath is a mountain range that's comparable to the Alps. And what they find is that there's actually a hydrology underneath the ice, and there's lakes and rivers submerged well down on the ground, way beneath the ice. And so we're understanding more and more, and this is important in global systems as well. We're having investigations going on all across the continent, and I love this graphic. It sort of lifts the ice off, and you can see, unlike when I was a kid and I'd see in textbooks, they'd show, maybe Antarctica without ice, and it was, rocky islands. But what we're learning is that there are actually lakes and rivers beneath the ice, and this liquid water beneath the ice influences how how the ice sheets move, and that will be important. As things get a little warmer, we're going to see, we're already seeing the ice shelves calving off, and we can better understand or predict how quickly these changes may happen and how they may affect other parts of the world. One of the really interesting developments in technology are high-resolution satellites, and how we use them here in the Antarctic. I'm not sure who first started it, but they were looking at these high-resolution images, and they were noticing a couple of small dark patches when they looked closely, and you can see that in the upper left there. There's a couple of large tabular icebergs frozen in the sea ice, and then you can see little dark patches nearby, and as you zoom in farther, you realize that those are penguin colonies. So they're emperor penguin colonies that we were able to see in satellites from space. So if you can see there's the pointer, right there is, and then as you zoom in, you see that it's actually, well, this is not from the satellite, obviously. They're not quite, well, if they're that good, we don't know about them. But what they see is so that when the penguins all get together, they color the ice differently. Penguin colonies, you're at a safe distance from them, but if you're ever walking through a penguin colony, they're great on the nature channels. But in person, there's a fragrance that you probably don't want to bring home with you. Anyway, so this is a way that we're getting an idea of what the penguin populations across the continent are without having to actually visit them. Because some of them are very logistically a challenge to get to. So that third area, the researchers who are coming down to not study Antarctica, they're coming down because the Antarctic provides a unique platform for the type of work that they're doing. One example are scientists who are looking at meteorites, and interestingly enough, 80% of all the meteorites found on the planet have been found in Antarctica. So 80%, but it's not, as I was asking someone, is that because there's something, they're coming at the pole or something like that? But it's not, it's because it's flat white on the polar plateau, and if you find rocks sitting on top of that, you're pretty sure they came from space. Whereas if you were looking for meteorites in Colorado, where I live, you'd have to really, really know what you're looking for. So that's one example. Others are, we have instrument packages that will launch on these high altitude balloons, and because of the vortex that goes around in the upper atmosphere, they can launch the balloon, let it ride the air currents in the upper atmosphere, and the balloon will come back to the area where they launched it. So they can launch it, let it ride 24 hours a day for like 45 days, and it'll come back, they release it, drops right near where you launched it. And if you tried that back home, you would have to launch it in California and fly to Europe to pick it up. Okay, so it's a great opportunity for us. And also, same with these packages, but at the South Pole, we have telescopes. This is the South Pole telescope, and to put it in perspective, you can see in the lower right, that's a person standing there. Very large instrument. It's set up at the South Pole because the South Pole is an excellent place to do astronomy. There are only two places in the world where you can watch an object or an area of the sky 24 hours a day, day after day. And the reason is you're at the pole. The other location is the North Pole, but because the North Pole is sea ice, you could never put an instrument like that there. So this is the only place on the planet you can set up an instrument like that. Okay? And so what you do is you point it at the area that you're interested in, and you essentially put it on a big turntable, and it just follows that 24 hours a day, because objects in the sky, including the sun, don't rise and set like they do back home. They just move straight across the sky. So at noon at South Pole, the sun will be over here, and at midnight, it'll be over here, but it just moves in a big circle. So it's pretty neat. So we do all this science in the Antarctic, but it's also very important. The National Science Foundation has one of the important parts of their mission is to do educational outreach. So not just do the research and learn the lessons, but get out there and share what they're learning, because of course we're publicly funded, so we want to make sure we're sharing. And that's one of the reasons, like I was mentioning, why we do these talks. Many of us, when we're back home, will go to schools and community centers and give talks as well. So hopefully give you a little appreciation of what we're doing here. Okay. Next. Oh, there we go. So the United States has 3 stations in the Antarctic. Palmer Station, where if you were up early, you might have seen the station. You picked us up about 3 miles away from the station. We're on the Antarctic Peninsula. We're the farthest north, and we're the smallest. We have a maximum population of 45 people. If you travel south as far as you can go, you get to the South Pole there in the middle. That's Amundsen Scott South Pole Station. I'll show you some pictures in a minute. And then over toward New Zealand, we have Mcmurdo Station, which is the largest station in the Antarctic with just over 1,000 people. South Pole Station, by the way, in the summertime has about 150 people. In the winter, down about 45. So this is Mcmurdo. Very large place. Okay, it's about 1,000 people. Very busy. McMurdo is a research station, of course, and we have researchers working in the immediate vicinity of McMurdo, but we also have people traveling out all across the continent, because McMurdo is also a logistics hub. It's where all of the supplies for South Pole come through McMurdo. All of the people going to South Pole or to the field camps move through McMurdo Station. Some of the other areas we visit, we have researchers, if you look in the lower right here, working in the dry valleys, which is a fascinating place. It's a site for a long-term ecological research project. There's 2 in the Antarctic, one at Palmer Station and one here in the dry valleys. We have some long-term field camps there that are trying to understand the microbiology and the geology of that area. It's a really fascinating area of the Antarctic, mostly snow-free. We also access field sites with small aircraft and snowmobiles. But if you're going to the South Pole, the only way to get there, well, there's 2 ways to get there now. One is if you're going to fly, you take a C-130, which is a cargo aircraft, and it can land on wheels or on skis. And it takes about 2-3 hours to get to the South Pole from McMurdo Station. The other way we get to South Pole is we have an overland traverse. And Dave Bresnahan, who's on board with you, and you've enjoyed some of his talks. I don't know if Dave's given the talk on the traverse, but we have an overland traverse that Dave was instrumental in setting up years ago. So if you are flying into the South Pole, this is it. Okay, bottom of the planet, as far south as you can go. Very scenic, not quite as scenic as the peninsula. Palmer Station has a better view. But this is the bright stripe that you see down the middle. That's the skiway. That's where the aircraft land. And the area just to the right of that is the station itself. So the station consists of a large building that has most of the facilities in there. It's built for 150 people. We do have other buildings in the area. And of course we have our observatories and our labs away from the station. They're actually on the left of that skiway. We have those farther from the station because they're doing radio astronomy, and so we want to get away from HF interference and things like that, radio interference. But anyway, the station is there right at the South Pole. So if you look in the lower right of this photo, you see that little stick there, this one right here. That's the South Pole. It's actually a pole. Put it in the ice. So that if you walk past that pole, you're going north. If you stop there, you're far south as you can go. Okay. If you're a geek like me, and I'll never forget my first trip to South Pole in 1993. I was so excited. As soon as they let us go, I ran out. I asked somebody, "Where's the South Pole?" And they pointed over there, and I ran in a circle around it. Made a real quick trip around the world. The pole that you see behind the sign there, the one with the mirrored ball and the stripes on it, that's the one you see in the cartoons, right? It's the South Pole, it's a barber pole. That's actually, we call that the Ceremonial South Pole, and that's where people take their photos. And it has flags around it of all the original signatories of the Antarctic Treaty. So the station is at the South Pole, and at night is where a lot of the astronomy happens. To see the night sky, we were just talking about this, to see the night sky at the South Pole is an unforgettable experience. it's sort of three-dimensional, and when the aurora are out, these are the aurora, the aurora australis, the southern lights. It is really, really amazing. Now, there's a price to be paid for seeing this. In order to go there, you pretty much have to spend a year to see the nighttime, because at the South Pole, of course, you have one sunset, which will be happening in just over a month. The sun will go down at the South Pole. It takes about 2 weeks to go below the horizon, and then a little later you get you start seeing the stars come out. The group at South Pole are isolated for 8 months. When I spent the winter there in 1996, there were 26 of us. So myself and 25 of my closest friends for 8 months of isolation. So you spend a year there. You see one sunset, and more importantly, and if you're lucky, you see one sunrise. So it was cloudy the day the sun started coming up for us. We saw it a few days later. But it is a really amazing experience to see the sunrise after so long. So we have those 3 stations. In addition, we have 2 research vessels. And the one on the left here is a very important one to us at Palmer Station. That is the Lawrence M. Gould, and she's actually up in Punta Arenas. They should be arriving another hour or 2 back to Punta Arenas. The Gould is a research vessel, and it's also our supply vessel. So that's how we get our people and our cargo to and from Palmer Station. So usually what happens is they come down to Palmer Station, they drop off cargo and people, then they'll go out on a research cruise for anywhere from a week to a month, and then they'll come back to Palmer, pick up people and cargo, go back to Punta Arenas. The ship on the right is the Nathaniel B. Palmer, named after the same person that the station is named after, Nathaniel Palmer. When the Palmer is working near the station, it gets a little confusing on the radio, because we're both called Palmer. But the Nathaniel Palmer is a 300-foot icebreaker, travels all around the continent, and in fact is working in the sea ice over just south of Tasmania on the Antarctic coast there. So they carry researchers all around the continent. And now the last but certainly not least is Palmer Station. This is what the station looks like from Arthur Harbor. It's the smallest of the stations, as I mentioned. It's also, as you could guess, the best of the 3 stations. We have the most awesome people working there. We have a comfortable station, and we do some really fascinating research. So inside the station, we have laboratories on the ground floor of one of our buildings. They're really flexible. We find out, we work with the researchers long before they arrive at Palmer so that we can have their labs set up so when they arrive, they can go right to work. And so these can be configured depending on what type of science they're going to do. Much of the research at Palmer is marine biology. So we have a great aquarium set up. This is a building with tanks so they can put the krill or the fish in the tanks and do their experiments. We also have refrigerated rooms where they can run experiments in controlled temperatures. And then we have outdoor tanks as well. When I first started in the Antarctic program, we didn't have very good communications. Email was just getting started. When I very first began the Antarctic program, I knew one person with an email address. That's how long ago it was. It really wasn't that long ago, but it feels like it now. Today at Palmer Station, we have a satellite link back to the States. It's not a super fast 3 megabit connection. Not super fast, probably about half the speed as if you have a slow connection at home. But we really like it because it allows us to have really good communication. We have phones at the station so we can keep in touch with our friends and family. And more importantly, it allows the science groups to collaborate with their colleagues back home. And in fact, as Mark will show you, we have, not through this satellite, but through an Iridium link, some of the instruments can actually be controlled remotely from the researchers back home can control them remotely. Very important, and he's on board, but I don't think he's here today, is our power plant. Without power, nothing happens in the Antarctic. So we have 2 diesel generators in one building, and we have an emergency backup. We have one person, and he's on board today, but he will not like me calling attention to him. But he does our power, our water, all of our vehicles, all our small engines, all one person. and we're very lucky to have him. We have to find very versatile people to work at Palmer Station. Versatile, and we're so fortunate to have them. Okay, also very important, we have a clinic. It's very well equipped. We have ultrasound, x-ray, things like that. It's sort of like an urgent care back home. And we have telemedicine so that if we get in a situation that's more than the doctor or physician is comfortable with, they can get a second opinion from doctors back in the States at University of Texas. Okay, life at Palmer Station, it's pretty comfortable, but it's not, you don't get a lot of privacy at Palmer Station. We have small rooms, but they're comfortable. A lot of people get reintroduced to bunk beds for the first time in a long time. Yeah, the rooms are comfortable. We get together for all different things when we're not working, which we're working 6 days a week at Palmer Station. We're well looked after by our chefs. We have 2 chefs at the station, and they cook 3 meals a day plus snacks and plus special events. They're working really hard, and actually Francis is here. You'll get to meet him in a minute. After dinner or whatever, if you want to try to keep the pounds off, you can use the gym. We have a small exercise room that's pretty well equipped. After hours, if you want to relax, play cards in the bar, or just hang out and visit with folks, we have a nice bar and a lounge. We have a home theater set up there, really comfortable. Mr. Bresnahan we were talking about this earlier. Dave helped us get our first home theater, so it's really very comfortable set up there. All right, so that's life at Palmer Station. I'd like to introduce Mark Dahlberg. Mark is our instrument tech at Palmer Station. He helps make sure that all of the scientific equipment is running, and you talk about really versatile people. Mark can fix just about anything, so we're really lucky to have him. So Mark is going to be sharing with you a little bit about the science that we're doing at Palmer. Thank you.
I'm relatively new to the U.S. Antarctic program. This is my 3rd season, and I've only been at Palmer, but I really like it there. So, as Bob said, oops, I went way fast. As Bob said, this is Palmer Station. It's situated on the shores of Anvers Island, and it's an ideal location to study marine biology and oceanography. So most of the scientists that come down, their research revolves around those disciplines. And in this part of the presentation, I'm going to introduce you to that science and how that science is conducted at Palmer. So the scientists don't take their samples right at station. They have to get off station to the water and the islands nearby. So we have a small fleet of inflatable Zodiacs that we run out of station. We can get to 2.5 to 3 miles away from station for the scientists to take those samples. So we're kind of restricted to a very small radius around station. And some of those Zodiacs are outfitted with a platform that has a davit and a winch, and using those, the scientists can lower instruments down into the water. They can take salinity measurements and temperature measurements. They can do net tows and capture plankton or krill that they're studying, or they can put water sampling bottles on and take water samples at various depths. They then bring those samples back to station for further analysis and processing. So there are 30 projects going on at Palmer this season, and for the next few slides I'm going to go over what some of those projects have been in the past and what some of them that are going on right now. In the past, we've had a group from University of Alabama come down, and they studied chemical ecology. What they're interested in are sessile benthic organisms. These are animals that are stuck down to the seafloor, things like sponges and tunicates and algae. Since these animals can't move and their predators are sea stars and amphipods, they don't have protective shells or anything like that. What they've done is they've developed chemical defenses, so they generate chemicals in their bodies that make them unpalatable or poisonous. And so what the group from University of Alabama does is they dive down and they take samples from the bottom and they bring them back to station, and they try to isolate the chemicals that these animals produce. And what they found is that some of the animals produce chemicals that can be useful for medicine in humans. So they found a sponge that has anti-malarial activity, an alga that has antiviral activity, and this tunicate could be used to fight skin cancer. These studies are in the preliminary phase, but it's research down avenues like this that can lead to major breakthroughs. So we have a group of entomologists from Ohio who come down and they study a wingless fly called Belgica antarctica. The adults of that species are about 3 millimeters long. They live on islands nearby, and they live on detritus in the soil or near nesting birds. And at 3 millimeters, these animals can be technically considered the largest living land animal in Antarctica. And if you're looking for an animal that doesn't migrate away from the continent and spends its entire life cycle on land, this is the animal that you'll find. Its larvae have interesting properties. They're also just a few millimeters long. They can survive through extreme environmental conditions. So they can be frozen solid. They can survive without oxygen for weeks. They can survive in a range of various pH conditions. And so these researchers would like to study the genetics of these animals to determine what is making them able to survive these extreme conditions. Another group studies the fish physiology of fish around Palmer Station. The fish that they study the most is the Antarctic Ice Fish, which is right here. And this fish has many unique properties, one of which is that it doesn't have a swim bladder. A swim bladder is what lets other fish swim up and down through the water column. Lacking a swim bladder, it's evolved a demineralized skeleton to make it lighter so it can float more easily through the water and catch things like krill that might swim up above the bottom. Another interesting trait of this fish is that it lacks hemoglobin in its blood. Hemoglobin is the molecule that's in red blood cells. It binds oxygen and helps oxygen get transported through the body. In fact, the 16 species of ice fish are the only known vertebrates to lack hemoglobin in their blood. If you compare the way the blood looks from the Antarctic ice fish and its close relative, the rock cod blood is very red and is shown here on the left, and on the right is the white blood of an ice fish. You can see that difference also in the coloration of the gills between the two fish. The ice fish has evolved an enlarged heart and also large diameter arteries and blood vessels to help conduct the blood through its body. And what it relies upon in order to get oxygen to different parts of its body is the high solubility of oxygen in the polar seawater because it's so cold. The oxygen is basically just dissolved directly in the fluid of its blood instead of being carried by red blood cells. So these researchers are interested in studying the differences between the rock cod and the ice fish. These traits that the rock cod has, the demineralized skeleton and the lack of hemoglobin, those are actually diseases in humans. So it would be osteoporosis and anemia. And so by studying the genetic differences between these two fish, they want to learn more about how these genetic diseases are created in man. So another major project at Palmer that Bob briefly mentioned is the Long-Term Ecological Research Project, or LTER for short. There are 28 different LTER sites that the National Science Foundation runs around the United States and its territories. At Palmer, there are 4 different groups that are involved in that research, and what they're interested in studying is the ecology of the area around Palmer Station as a whole. So there's a group that studies the bacteria in the seawater, there's a group that studies phytoplankton, one that studies zooplankton like krill, and another one that studies apex predators like penguins and seabirds and whales. They've been taking data, or they have a data set that stretches back to 1976. And so they've been able to see a lot of the changes that have occurred at Palmer, and there have been quite a lot of changes. One of which is the retreat of the glacier around the station. This picture is a satellite image of Palmer Station. Palmer Station is